Okay guys, so this is section 1.6, the angle addition postulate and angled bisectors. And then today's I can statements are I can perform and explain the construction of geometric figures using a variety of tools and methods. We're talking specifically about angled bisectors with that I can statement. And then I can use the properties of angled bisectors to find the measures of angles. So go ahead and pause the video and carefully write down the definition of angle addition postulate. Also copy down the picture. Okay, so the definition of angle addition postulate says that if point P is in the interior of angle RST, so again, look what's going on. Here's a bigger angle RST, and then I have point P on the interior, and SP is a ray. Okay, so it's like I have two little angles and they're going to give me a larger angle. That's what this says. Okay, it says if we have two smaller angles, so we had measure of angle RSP plus measure of angle PST, then you're going to get the measure of angle RST. Very similar to the segment addition postulate in that it's a part plus part equals the whole situation. Part plus part equals the whole. So you just got to think to yourself, okay, well, what are the two parts? And then what's the whole? What are the two parts? And then what's the whole? So that's what's going on here. I had RSP and PST. Since P is on the interior of the larger angle, then those two angles add up to the larger angle. I think it's easiest to understand the angle addition postulate when you can go through and look at an example that uses it. So in example 1, it says use the angle addition postulate to name the sum angle. Name it in two different ways if possible. So if we look at the diagram and we look at question number 1, I'll try to color code everything to make it as clear as possible. We are told that we have the measure of angle 1 plus the measure of angle 2. So I'm going to go ahead and add that to our diagram. Measure of angle 1, I'm going to do in orange. Measure of angle 2, I'm going to do in that navy color. So I'm taking those two smaller angles and I'm adding them up. So we need to figure out what the whole is going to be. So it's got to include angle 1 and angle 2. So that means that the whole is going to be the measure of angle ABE. ABE. Because that is the angle that you get when you add up angle 1 and angle 2. We were also told to name it in two different ways if possible. So measure of angle EBA would be another way of saying that. Remember, when you're naming angles, the vertex has to be in the middle. The order of the two other points does not matter. Okay, now we can look at the next example, measure of angle 2 and measure of angle 3. So I want to look at measure of angle 2 on my graph. So that's going to be the same angle 2 we used before. Oops, sorry. I said I'd put it in yellow though. Here we go. So it's in yellow now. And then the measure of angle 3 I'm going to do in that kind of baby blue color. So I need the angle that is the combination of those two. So angle 2 plus angle 3, well, if you look carefully, I'm going to get angle DBC, angle DBC. So measure of angle 2 plus measure of angle 3 gives me measure of angle DBC. Again, I found the two parts and then I figured out what the whole would be. You could also name it the other way, measure of angle CBD. The reason I'm using the little measure, the little M to show that it's the measurement of an angle is because I'm dealing with an equal sign, and also I'm already given that notation at the first part of the problem, so I want to keep it consistent. We're also talking about angle measures. Okay, now I'll use the highlighter because I'm running out of colors, and we are now going to be talking about taking a larger section. So we're actually taking the whole quantity and we're removing a part, and we want to see what's left. So for question number 3, it says the measure of angle DBC, and then we're going to take away angle 3. So DBC, I'm going to do in purple highlighter. And then I'm going to remove angle 3. And angle 3 I've actually already done in this baby blue color, so I'm just going to leave it. So I want to take that purple highlighted angle and I want to remove angle 3. So what am I going to have left? All I'm going to have left is angle 2. So the measure of angle 2. It did say though that I want 2 different ways if possible. So instead of saying the measure of angle 2, you could also say the measure of angle, and then you can use the letters. So DBE or EBD. So I actually went above and beyond. Go Miss Colebank. I named it in 3 ways. So if you take that highlighter purple angle, which is DBC, and you subtract angle 3 from it, you're going to be left with angle 2, which you can say in any of those 3 ways. Lastly, it says measure of angle ABC minus angle 1. So again, let me go to my highlighter. I'll do it in bright green. So ABC is actually this entire picture. ABC is this entire angle. And I want to remove angle 1, which is currently in orange, so I'll leave it orange. So I'm taking that whole green angle and I'm removing just the orange part. So what I'm going to be left with is angle 2 and 3 put together. So that's angle what? DBC. And it's actually in red already. So measure of angle DBC or measure of angle CBD. So again, I took the entire thing and I removed angle 1. So I'm left with just the part in red, which is angle 2 and 3 put together. All right, so we jumped right in with the angle addition postulate. Again, if you can remember part plus part equals whole, that's going to be really, really helpful moving forward with this. So let's do example 2. If measure of angle CDE is 62 degrees, let's go ahead, guys. Put that on your graph. Put that on your diagram. So CDE is 62 degrees. And then we're told that measure of angle EDF is 18 degrees. So this is 18 degrees. It says find the measure of CDF. So we can go back and look at our angle addition postulate that says if P is in the interior of RST, and we do want to check that point E is on the interior of CDF before we can apply the angle addition postulate. It's in the perfect position, so that means we can set up the angle addition postulate for this example. Part plus part equals whole. So measure of angle CDE plus measure of angle EDF equals the whole, which would be the measure of angle CDF. If I'm moving too fast, pause the video and think about that for a second. I just added up the red angle plus the sort of pinkish angle, and I should get the total angle. And then what I can do is substitute in what I know. So I know that the measure of angle CDE is 62 degrees. I know that the measure of angle EDF is 18 degrees. And that is going to give me the measure of angle CDF. So once I simplify that, the measure of angle CDF equals 80 degrees. If you want to think back to yesterday's lesson, tell me 80 degrees is what type of angle? I'll wait. It is an acute angle. So if you got that, hopefully you've remembered what we did in the last couple days, and you would remember that that is acute because it's less than 90 degrees. Example 3. Again, let's go through and label everything. So if measure of angle QST, so let's be really careful on this. I'm going from Q to S to T. Okay, so that's going to be the entire combination. So I have 2 parts. They've added up to QST, which is 99 degrees. Find the measure of angle RST. So I'm given the entire measurement. I'm given a part, 52 degrees, and I need to solve for another part. So let's set up this angle addition postulate. I know that R is in the middle, so I can take one part, add it to the other part, and I'll get the whole. So let's start out doing that just with the equation. The measure of angle QSR, which is the one in blue, plus the measure of angle RST, so part plus part, equals the measure of angle QST. And then super similar to the segment addition postulate, substitute in what you know. So I know that the measure of angle QSR is 52 degrees. I don't know what the measure of angle RST is. And I know that the measure of angle QST is 99. And then what you're going to want to do is you're going to want to use solving equations. So I need the measure of angle RST. That's what I don't know. But all that's happening to that right now is 52 degrees is being added to it. So if I subtract 52 from both sides, I will get my measure of angle RST. So the measure of angle RST would be 47 degrees. The measure of angle RST would be 47 degrees. I know I'm moving quick on some of these, but it's mainly because you can pause. And hopefully I was nice and gave you plenty of time to watch the video. I'm sure I did. Okay, one more example on this front page, and then we're going to add a new definition. So example 4 says, given that angle KLM is a straight angle, find the measure of angle KLN and the measure of angle NLM. So again, let's label, because I don't know about you, but that's a lot of letters and I need to help my brain out. So KLM is a straight angle. Think for a second, what is the measurement of a straight angle? If you said anything but 180 degrees, we got to go back and practice. So a straight angle is 180 degrees. So on my diagram, KLM, K to L to M, that whole thing is 180 degrees. 180. So think to yourself, based on my picture, based on where all the points are located, is that going to be one of the parts or is that going to be the whole? One of the parts or is that going to be the whole? Then we're told that the measure of angle KLN is one of the things we're looking for. So I need to find the measure of angle KLN. I'm given some variables, so I'm probably going to use those to solve for X. And then I also need to find the measure of angle NLM. So let's go ahead, we'll set up the angle addition postulate. What the angle addition postulate says is that I can take the two smaller angles. So I can take the measure of angle KLN. Sorry, here we go. KLN. I can add to it the other part, so the measure of angle NLM, and I will get the whole angle, so measure of angle KLM. You have to be able to do that first because we have to be able to substitute in what we know, especially when we have a question with variables in it. So now I'm going to go through and I'm going to replace measure of angle KLM with 10x minus 5. I'm going to add in what the measure of angle NLM is, which is 4x plus 3. And then I'm going to write in what the measure of angle KLM is. Well, remember, it's a straight angle, so that's going to be 180. 180. So even though the setup's kind of tricky, now I have an equation that I've seen before. All my variables are already on one side, which is nice. I just need to combine like terms, and then I'll be able to solve for my x value. So I have 10x plus 4x, that's going to give me 14x, plus I have negative 5 and positive 3, so actually it's not going to be plus, it's going to be minus 2. That equals 180. And I'm going to need to finish simplifying for x by adding 2 to both sides. I get that 14x equals 182. And then I'm going to divide both sides by 14 to get the x equals 13. I'm going to move this around a little because I'm not actually done. I need to also figure out what the 2 parts measures are. So I need to figure out the measure of KLN and the measure of NLM. And the way I'm going to do that is just plug in my x value. So x equals 13. So I'm going to have 10 times 13 minus 5, which is 130 minus 5, which is 125. So that's the measure of angle KLN. And then I'm going to also plug in 13 for NLM. So 4 times 13 plus 3. 4 times 13 gets me 52 plus 3. Hope that's right. I think it is. And then 52 plus 3 gives me 55 degrees. Oh, it is right. I know because those two add up to 180 degrees. Love it when that works out. Again, all this work is posted if you're falling behind, or you're welcome to pause the video. So now we're going to move on to the back. And this is where we're going to talk about angle bisectors. So angle bisectors we're going to do a little bit differently because we need to figure out what angle bisector means, and then we're going to be setting up questions differently. So first off, remember, what does it mean to bisect something? What does it mean to bisect something? It's really important that we remember that. And bisecting just means to cut in half. So if you have any type of bisector, that thing in geometry is cutting something in half. So if you look under key concept, write down the definition. Angle bisector is a ray that divides an angle into 2 congruent angles. Remember that congruent angles have the same angle measure. So if you look at this picture, I have angle XYZ that has been chopped in half by ray YW. So ray YW is the angle bisector. So we're going to do 2 examples. Example 5, it says ray EG is an angle bisector of angle DEF. Find the 2 angle measures not given in the diagram. So if I look at example A, I have one of the parts. I need to find the angle for the other part, and they're the same. And then I need to find the total angle because that's what I'm missing. So I know one angle right now. I know that the measure of angle GEF equals 52 degrees. But because EG is an angle bisector, I also know that the measure of angle DEG equals 52 degrees as well. If I wanted to find the total, I can use that angle addition postulate, add up the 2 parts, and I will get the measure of the whole angle, so measure of angle DEF rather, and that's going to be 104 degrees. Measure of angle DEF is 104 degrees. Same thing on the next example, except I'm given the whole instead of the part. So the entire measure is 64 degrees. Measure of angle DEF is 64 degrees. And EG is a bisector, so that means that those 2 angles have the same value but are going to add up to 64 degrees. So you can probably do that in your head. Half of 64 is 32 degrees. So that's going to be the measure of angle DEG and the measure of angle GEF. Okay, so we are going to do example 6 and then example 7 and we'll be done. Example 6 says, using the information below, find the measure of all angles. One really important aspect of this diagram is the fact that there are arcs on angles ABD and DBC. So I can assume that ray BD is an angle bisector because I know that those two angles are congruent. So the first thing I would do if I was trying to find the measure of angle ABD and then the measure of angle DBC is you have to figure out what x equals, because those angle measures are based on an x value and we don't have an x value right now. So what we can do, since we know we have a bisector, is we can say that measure of angle ABD is equal to the measure of angle DBC. I know that because I'm dealing with an angle bisector, which is the ray BD. And I can set 9x plus 10 equal to 13x minus 6. Again, when we are dealing with congruent angles, you are always looking for what you can set equal to each other. So we know that those two angles are congruent, so they have the same measure. So that means if there's variables, you can set those equal to each other as well. Now I'll be able to solve this equation. So I want to move all my variables to one side. I like to subtract the smaller variable, so I'm going to subtract 9x from both sides. I get that 10 equals 4x minus 6. Then I'm going to add 6 to both sides. I get that 4x equals 16. And then divide both sides by 4, and I get that x equals 4. So I now have an x value that is going to allow me to figure out the measure of angle ABD and the measure of angle DBC. So the measure of angle ABD is equal to 9 times x plus 10. So I'm going to have 9 times 4 plus 10, which is 36 plus 10, so 46. So that's going to be the measure of angle ABD. If you remember, they're congruent, so this will also be 46. And then it says of all the angles, so I would also probably want to do the total measure, which is the measure of angle ABC. And it's going to be both of these added together, so 92 degrees. So again, we set up an equation so that we could solve for x, and then I was able to find the measure of the two parts of the bigger angle and then the measure of the bigger angle itself. Okay, so example 7 is very similar. BD is an angle bisector of angle ABC. Find the measures of ABD and DBC. So very similar to the one we did above. In fact, all of the lettering is the exact same. The first thing you're going to want to do is figure out what two angles are equal. ABC is bisected, so the measure of angle ABD is equal to the measure of angle DBC. That's actually going to be true on both of these because all the lettering is the same. And then you can go ahead and swap in what I know. So I have 3x equals x plus 20, 6x plus 15 equals 10x minus 25. So go ahead, take a minute to try and solve both of those equations, and then I will tell you what x equals and what the different angle measures are. So on A, you would subtract x from both sides. You'd get that 2x equals 20. And then when you divide both sides by 2, you get that x equals 10. So my x value is 10. And then the measure of angle ABD equals 3 times 10, so 30 degrees. And then they're congruent, so the measure of angle DBC is also 30 degrees. The nice thing about this example is I only asked for those 2 measures. I did not ask for the overall measure, even though we know that would be 60 degrees. And then on the second one, I'm going to solve for x as well and then do the same thing. So move all your x's to one side. I'm going to subtract 6x from both sides. So I get 15 equals 4x minus 25. Then I can add 25 to both sides. I get that 4x equals 40. Divide both sides by 4. I get that x equals 10. And then I would have to plug that in for both of those. So I'm going to just plug in the one that looks easiest, which is 10 times 10. So 10 times 10 is 100 minus 25 would give me, what, 75 degrees? So the final answer on that one is the measure of angle ABD equals 75 degrees. And the measure of angle DBC also equals 75 degrees. So I know that was a long lesson. Thanks for staying along with me. I also have the key posted, and then you're going to be able to ask me questions right after this. Thanks. Bye.